This week, we'll continue extending our plotting script from last week, but using some dictionaries to hold plot settings to make your code even more versatile and compact. Welcome to another MetPy Monday. Hello, I'm John Lehman, a software engineer for Unidata. On this week's MetPy Monday, we're going to keep talking about plotting, but learn how we can make those plots a little bit more styled and different. Last week, we made several plots, up to as many as we wanted, using some looping techniques and using subplots to generate all those axes for us and store it in an array of axes. But all the plots looked the same. So this week, we're going to see how to make those plots different based on the name of the column or the name of the data series in a pandas data frame. So let's go ahead and get started with some imports. I'm going to import NumPy as NP. We're going to import pandas as PD. And of course, matplotlib.pyplot as PLT. We'll use the matplotlib inline magic so that our plots show up in the notebook. And like last week, we need some fake data. So I'm going to make a station data, in this case, a data frame. So to build a data frame, there are several ways you can do it, and I've talked about those. The way that I like the most is using a dictionary. So let's make a dictionary to start with. Curly braces, our key, which is going to be temperature, and then a colon, and then our value. So mp.random.random. In this case, we'll make it a 100 length array multiplied by 25. I'll do the same thing for the next key, which is going to be pressure. mp.random.random, 100 elements. In this case, I'm going to add 1012 just to get us in a more realistic range of values. And then for humidity, mp.random.random, 100 elements, and we will add 65. So that gives us a dictionary. Not quite a data frame, but we can make it that very easily by wrapping that dictionary in a call to pd.dataframe. And go ahead and indent everything so that it lines up nicely. And now we can run that cell, and if we look at station data, there's our data frame. So next, I'm going to make a dictionary that holds plot settings. I'm going to call it PlotSettings. And the key is going to be the name of the data series in that pandas data frame that I want to store plot settings for. So let's say pressure. It's not order dependent at all here. Remember, dictionaries were not ordered until recently. So what could I use for the value here? Well, I could use a list. So I could say something like, I want it to be a black line with a line width of 1 and a line style of dash. That is not the most versatile construct that we could use. We have to remember that index 0 is the color, index 1 is the line width, and index 2 is the line style. And if we want to add something, then it might be a little difficult. And we have to specify those for each thing that we're going to plot. Maybe we want a default plotting case, though. So dictionaries are another good choice here. So we get rid of that list. And now the value to this key in a dictionary is going to be another dictionary. In that dictionary, the first key is going to be color. The value is going to be black. The second key is going to be line style. And we should put that in quotes since it's a string. Maybe I'll make it a dashed line. or we could even go a little fancier. We'll go a dash dot line. Okay, so next thing in my outer dictionary, if you will, temperature. Its value is another dictionary. The color is going to be tab red. And that's it. Then humidity. Color will be tab green. And let's set the line width to be 2 here. Okay, so now we've got those plotting parameters stored. And so you see I've got a name error because this one is not enclosed in quotes. Okay, there we go. So now we've got all of that stored in our dictionary. So now we're actually going to write our plotting code. So I'm going to see how many fields I have by looking at the shape of my data frame. So station data.shape, and I'm going to want the 1th index out of that, or how many columns or data series are there. Just like last week, I'm going to create my figure and axes simultaneously with plot.subplots. In rows is going to be our in fields. So we want however many rows of plots for however many fields our station recorded. For the fig size, I'm going to use a tuple of 12 and 4 inches. And I'm going to make them share an x-axis. So already, this is pretty versatile. We could add another field to our data, and we would just plot it automatically. But we don't have plot settings for it, you say, and that is where some of the magic of using dictionaries here comes in. So next I'm going to need a loop. So I'm going to say for field in station data.columns. So that will give me a way to loop over each of the data series in that data frame. And then now I need to be able to get the appropriate axes to plot on, which remember in this case is going to be an integer. So I need some way to have an axis number. This is a great use case for enumerate. So I say axnum n field in enumerate station data.columns. So what that's going to do is for each thing in station data.columns, it will create a tuple, the first element of which is a 0-based counter and the second element of which is the thing. So that gives us a convenient way to count here without having to use a counter variable. So we're then going to call .plot. We will plot our station data and then the field name. Remember, you can use this dictionary-like access to pandas data series inside a data frame. So the color is going to be equal to color, line style equal to line style, and line width equal to line width. Now we have to define what those things are. And you notice I'm not writing this code linearly. I'm sort of filling in where I know I'm going to need these things, and then I'll go back up above or below and actually create them. So it's not a straight through process many times when you're writing code. So the first thing I'm going to need is, say, to get at the color, but that is in a dictionary inside a dictionary. To prevent things from getting complicated looking and hard to read, I'm going to first create a variable called field settings and use it to store a dictionary from plot settings. So plotsettings.get field will go get this key and return its value, and we'll store that as field settings. So now field settings is a single dictionary and a lot easier to access. So now in that dictionary, let's go ahead and get the color out. So the color is going to be field settings.get and then the name of the field. So color. Same with line style. And the same with line width. Now, not all of these dictionaries have line style and line width. The first one just has line style, the second one has neither, and the third one just has line width. So it's useful, and the reason that I use the .get method here to access these is we can specify a default. So I can say if the color key doesn't exist, we're going to default to black. If line style doesn't exist, we're going to default to a solid line. And if line width doesn't exist, we're going to default to 1 point. Okay, so let's run that and see what happens. So we now have 3 plots, each of which are styled uniquely based on the name of their field stored here. And we'll look at ways in future MetPy Mondays how to move this out into a file that a user could pretty easily edit, like a settings file. But this is already getting pretty straightforward to edit. And you might say, well, I don't want to have to hard code all of these gets. And that's another topic for another MetPy Monday as well, is there are ways to do this a little bit more intelligently. But for just a few parameters, this isn't too bad. And it's pretty flexible. So I can go back up here in my original data creation, and I'm going to create another variable. Let's say solar radiation. So I'll create some random data. We'll add 1,000 watts per square meter. We move our curly brace. Okay. Now I'm not going to change my plot settings at all. I'm just going to rerun these next 2 cells. And we have a small problem. So when we are calling this field settings by PlotSettings.get, we're returning a none. That's the default that comes back if it doesn't exist. So then we try to call .get on none, and that's not a very happy thing. So let's return an empty dictionary. Now that we're returning an empty dictionary, we can call .get on a dictionary even if it has nothing in it, and everything works happily, and we have our defaults down here being plotted for a new field. So it's a really easy and versatile way to expand your plotting horizons and not add a whole lot of burdensome many lines of code to maintain. I hope that you found this useful, and I'll see you on next week's MetPy Monday.